Next question is, I want to type this question also. The offensive smell Let us do this problem. I type this problem, you see. A solution of 10 ml of m by 10 solution of 10 ml of m by 10 ferrous sulfate FeSO4 is titrated against KMnO4 solution in acidic medium. The amount of KMnO4 needed will be the amount of KMnO4 needed will be, three options are given. Five ml of 0.1 molar KMnO4, 10 ml of 0.02 molar KMnO4, 10 ml of 0.1 molar KMnO4, then 10 ml of 0.04 molar KMnO4. This is the question asked. So look here. Ferrous sulfate 10 ml, m by 10 means a 0.1 molar solution. Therefore, volume into strength comes out to be 1. In the given answers, 1 mole of KMnO4 will oxidize 5 moles of FeSO4. Equivalence is 5. Therefore, this will be equal to 5 into, you put the first answer, 5 into 10 ml, 5 into 10 ml into 0.02 comes out to be 1. Whereas if you put any other thing, 5 into 10 into 0.1 will be 5. First answer. Second answer, 5 into 10 into 0.02 will be, how much it is? Be 10.2. It will be 1, right? So third answer, 5 into 10 into 0.1 will be, this is 5 into 5. 10 means 0.2. This would be 50.5. Therefore, the correct answer is this one. 5 into 10 into 0.02. This is the correct answer. The idea behind this problem is why this 5 is included, that's all. Because for the oxidation of ferrous sulfate, 1 electron is needed, but 1 KMnO4 molecule can liberate 5 electron. Therefore, 5 times the strength and volume will be this unit. Therefore, 10 ml of 0.1 molar ferrous sulfate is equivalent to 10 ml of 0.2 molar KMnO4 because this produces 5 electron. This consumes 1 electron. Therefore, if you multiply on this side also it is 1, on that side also it is 1. This is how the equivalence is calculated. I suppose you understand this problem. I read the problem. In the reaction of a KMnO4 with oxalate in acidic medium, MnO4 is reduced to MnO4 minus is reduced to Mn2 plus, and the oxalate ion is oxidized to CO2. Hence, 50 ml of 0.2 molar KMnO4 is equivalent to what? It's very simple. Equivalent weight of KMnO4 is molecular weight by 5, whereas equivalent weight of oxalic acid is molecular weight by 2. Therefore, here the factor is 2, here the factor is 5. Therefore, what is taken is 50 ml into the valency 5 into 0.2 molarity. This comes out to be 5 equivalents. Now calculate the equivalence of all these things and find out which matches. So 100 into 2 into 0.05 will come out to be, it is 0.1, so 10 equivalents. So this is of KMnO4. This is of KMnO4. Is the first answer. Second answer, 50 into 2 into 0.05 will come out to be 25, 100. So it is 5.1. So 5. Third one is 25 into 2 into 0.02 will come out to be 0.024. It is 0.1. And the fourth answer will be 50 into 2 multiplied by 0.1 will come out to be 0.1, 0.2. It will be 1. Therefore, the right answer is, this is the correct answer. Equivalence, here also it is 5 milliequivalents. Here also it is 5 milliequivalents. So the main idea is the number of electron transfer or the valency has to be included. So volume multiplied by normality will be equal to volume multiplied by normality. But instead of normality, molarity is given, means in both sides that molarity has to be multiplied by the valency on both sides. Only when these two units are equal, then the equivalence is reached. I suppose you understand this idea. In 1 mole solution that containing 0.5 mole of the solute, what is the weight of the solvent to be taken? So molality is number of moles of solute present in 1000 gram of the solvent. 1 molar solution means 1 mole of solvent present in 1000 gram of the solvent. Therefore, if a 0.5 mole of a solute is taken, that has to be dissolved in 500 gram so that you will get 1 molar solution. So, here you have to do weight of solute taken. This calculation is very important. Weight of solute taken divided by molecular weight of the solute. So that will give you the number of moles. Then this entire factor, this will give you number of moles of solute. Number of moles of solute. If this is taken in a particular weight of the solvent divided by weight of the solvent, then what would be the number of moles present in 1000 gram of the solvent? This is molality. Suppose if you take molecular weight of solute to be M2 and the weight of solute to be W2 and the weight of solvent to be W1, then W2 by M2 divided by W1 into 1000 will give you molality. This calculation is also involved in the calculation of colligative properties. I suppose you understand this problem. The density of a 2 molar aqueous solution of NaOH is 1.28 gram per centimeter cube. Number of problems are asked like this. First of all, it is a 2 molar solution, which means 2 moles of NaOH are present in 1000 ml of the solution. This is the meaning of the first sentence. 2 molar solution means 2 moles of NaOH is present in 1000 ml of the solution. Now, what is the weight of this 1000 ml? Already the density is given. 1 centimeter cube weighs 1.28 gram. Therefore, 1.28 gram multiplied by 1000. 1000 cc is 1 liter is equal to 1280 gram. So this is the weight of the solution. This is the weight of the solution. This solution is containing 2 moles of this solution is containing 2 moles of NaOH. So the 2 moles of NaOH weight will be 1 mole is 40. Therefore, these 2 moles of NaOH will be 80 gram. So 80 gram NaOH is dissolved in 1280 minus 80 gram of the solvent. So solvent weight and solute weight are calculated. So 80 gram NaOH is dissolved in 1200 gram of solvent. In other words, 2 moles of NaOH is dissolved in 1200 gram of the solvent. What would be the number of moles of NaOH present? 1000 gram of the solvent. That is molality. Therefore, 2 divided by 1200 into 1000. If 1200 gram contains 2 mole, what will be the amount of NaOH present in 1000 gram of the solvent? Therefore, it is 1.67 molal. 1.67 molal. What is the mole fraction of the solute in 1 molal aqueous solution? What is the mole fraction of the solute in 1 molal aqueous solution? 1 molal solution means 1 mole of solute in 1000 gram of the solvent. So it is an aqueous solution. Therefore, 1000 gram of water is taken. 1000 gram of water will contain 1000 divided by 18 moles. Weight taken by molecular weight. 1000 by 18 will become 55.5 mole. So now solute 1 mole, solvent 55.5 mole. So you want to calculate mole fraction of solute. Mole fraction of solute. So mole fraction of solute is number of moles of solute divided by total number of moles, 55.5 plus 1. So it is 1 by 56.5, which is equal to 0.0177. So 0.0177 is the mole fraction of a solute in 1 molar aqueous solution. How many grams of concentrated nitric acid solution should be used to prepare 250 ml 2 molar nitric acid? Concentration of the acid is 70%. See, we are going to prepare molar. So molarity is equal to weight taken per liter divided by molecular weight. From this problem, the weight taken per liter is equal to molarity multiplied by molecular weight. I just cross multiplying. So this is equal to molarity is 2 molar, molecular weight is 63. So that is equal to this much of weight has to be taken for 1 liter. But we have to prepare only 250 ml. Therefore, 1/4 of this weight is sufficient. So for 250 ml, 2 into 63 by 4. So that is equal to 31.5 gram of nitric acid has to be dissolved in 250 ml to prepare 2 molar solution. But it is only 70% concentrated. If it were 100%, then 31.5 gram is sufficient, but it is only 70%. Therefore, 31.5 gram divided by 70 into 100. What it be? It should be for 100. Therefore, you have to weigh 45 gram of nitric acid and dissolve in 250 ml of water, and you will be getting 2 molar solution.
Yes, sir.
25.3 gram of sodium carbonate is dissolved. You have to find out the concentration of sodium plus ion and carbonate ion in molarity. Look here, sodium carbonate molecular weight is sodium carbonate molecular weight is 106. So 25.3 gram will contain 0.24 mole. 0.24 mole. 0.24 mole is dissolved in 250 ml. So 1 liter will contain 4 times. So 0.24 into 4, it is 0.96 molar solution. That is, a sodium carbonate solution itself is 0.96 molar solution. If you take a sodium plus ion only, sodium carbonate gives 2 sodium plus ions. Therefore, it will be 2 into 0.96 molar sodium plus ion solution. It is 1.910 molar sodium plus ion solution. Carbonate, it is 0.96 molar carbonate ion solution.